Hello everyone. Today we will talk about updating state, and then we'll move to state management section. So updating array in state. Arrays are mutable in JavaScript. Like any non-primitive reference type, arrays, objects, and functions are basically uh, mutable, and we can mutate them like primitives are immutable, but we can treat them as immutable with some tricks, and by the way, by using some libraries like Emerge.js, which will come later. So let's go. But you should treat them as a immutable. In React we should treat, I mean, everything which is flowing via props and state or context or any, I mean, React data flow, we should treat it like immutable. When you store them in state, just like with objects, when you want to update an array stored in a state, you need to create a new one or make a copy of the existent one and then set state to a new array. In state, any data we play with, we must treat it, not just treat, but keep, I mean, eye on a immutability. Data must should be immutable. Okay, how to add, remove, change items in an array, how to update, how to make array copying less repetitive with immer. Okay, updating array without mutation. In JavaScript, array are just another kind of objects. Like object, you should treat arrays React in a React state as read-only. This means that you shouldn't reassign them inside array like arr at 0 is equal to bird, and you also shouldn't use methods like mutable, push, and pop. Okay. Instead, every time you want to update an array, you will pass a new array to your state and setting function to do that, and you can create a new array original from the original array in your state by calling non-mutating methods like filter and map. I mean, map and filter are higher order function and they return a new array. Then you can set your state to the resulting new array. Okay, here is a reference table of common array operation. When dealing with array inside React state, you will need to avoid methods in a left column: push, shift, pop, unshift, splice, and all of this. I mean, for adding, we will use concat or spread operator. Okay, for removing, we will use filter or slice. Okay, for replacing, we will not use this syntax, but we'll use map. For sorting, we will use reverse or sort. We will not use reverse or sort. We will go through example and got it. Unfortunately, slice and splice are named similarly but are very different. Slice lets you copy an array as a part of it. Okay, so we must have to go with slice. Okay, splice mutates array. We should not use splice in React state. In React, you will be using slice no p a lot more often because you don't want to mutate objects in array. Instead, updating objects explain what mutation and why it's not recommended for state. This must be an older one. What is mutation? Treat state as a read only. I mean, we went through this earlier. Okay, adding to array. Push will mutate array which you don't want to use. Okay, then we should not use this. And what's going on? I don't know. artists. We are not doing a set state. Okay. Set name. We got a name. I mean, this will not work. I think. Instead, create a new array which contains a spread operator. Dot dot dot. Previous array, and then now it will work like a charm, but here it will not work. I mean, oh, it's working, but no, it's working pretty bad way. And here it's working seamless. Reset. Let next id is equal to 0. Id is equal to next id plus plus. But this function is not pure. We should not deal with any outsider thing. Okay, but here, I mean, we need to keep it pure. Not pure, basically, because I mean, this ID came from generally from database somehow. And we are simulating here, so that's why the array spread syntax also lets you prepend an item by placing before dot 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 artist. Okay, I mean, we can put it down or above, doesn't matter really. The spread can do job of both push and unshift. Okay, I mean, if we put it here, right, it will be do push job. Here it will do unshift job. Okay, removing from an array. I mean, delete, we will use filter, I think, or map maybe. Let's go through code. Use state initial artist. Okay, this is the array of objects. We are returning this, and there must be a button. Delete. Okay, on button, set artist filter a.id id, and not is equal to artist.id. Okay, there is an id. Okay, got it. We're filtering based on IDs. Okay, transforming an array. We will use map. I mean map and return shape.type square, return shape no change, else return dot dot dot, and move circle down. Okay, I mean, we are taking an idea of things. I mean, I'm not trying to, I mean, go through, I mean, like, try these examples because they're really straightforward for me at least. And after going through objects and arrays are same, that's why I'm little bit skimming, but good to go. Replacing items in array. In particularly common way to want to replace one with other item, you will want to use map for this. Okay, okay, we can use map also. Inserting into array dot 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 syntax again, and slice maybe. Okay, I mean, if we wanna, I mean, avoid all of this jargon and keep in mind when to do what, making other changes to an array, we can use filter. Okay, if we don't wanna, I mean, remember all of above stuff. Okay, all above stuff, we can go just updating on inside it array. I mean, look, we don't wanna. I mean, I don't wanna remember this and come to this documentation when I wanna update an array. We just can use, I think, emerge.js. Here section will come. I mean, using spreads and whatnot. Yeah, right here. So generally, you shouldn't need to update state more than a couple levels deep. If your state objects are very deep, you might restructure them differently so that they are flat. If you don't want to change state structure, you might prefer immer, which lets you write using the convenient but mutating stacks that takes care of producing copies for you. I mean, use immer, I think, for if you're using instead objects or arrays or any data type which is mutable, use immer. This is pretty straightforward. I mean, look, we should go through this code. Use state, use immer, let next id is equal to 3, initial state this is, okay, my list and update my list, initial list, okay, your list, update your list, initial list, handle toggle to my list, okay, update my list and draft, and arrow function const network is equal to draft artwork, oh sorry, draft.find a dot id is equal to id. I mean, we're using find method just straight, okay, just use draft dot and artwork dot scene, next scene, your list, okay, art in buckle, okay, on toggle, okay, we are adding and removing toggles, okay, checked, I mean checked here is okay. I mean, this level of work is being done in UI libraries, and we should, I mean, care about this. If we wanna good guys, I mean, we wanna write our own little component somehow, like in some stage, function item lists, artwork. Artwork is an array, and we are list iterating through an array and input type checkbox. Okay, checked artwork dot scene. I mean, what we are doing in scene. Next scene. I mean, next scene is what? Next scene is being provided from here. Okay, little bit mind-boggling code, but I don't want to go through this. But the main idea of this code is use this draft. Okay, and instead of using use state, use immer. Okay, and put your state and then update via draft, whether you are in object or in array, it really don't matter, just use their methods. I mean, draft dot what, draft dot find, filter, map, push, pop, whatever. Okay, we will, I mean, I think I'll go through immer.js again. I think I don't need to do exercises. This is another time to do exercises basically, because I want to jump to next section today. This was really skimming through. And by the way, immer.js, I mean, we must have to go through this really. I mean, there. read producer procedures, React animal. I mean, we use state plus immer. Okay, we should go this way. I mean, this is what interesting. Redux plus immer, use immer reducer. Okay, use reducer plus immer, use immer, use state plus immer. Okay, I think I should learn whole immer, not just React animal, but advanced features. I don't want to go through this. Resources, yeah. It was supporting posting documentation. I'm all in documentation. Support him. Okay, we have to go through this. I mean, really soon I learn Immer in depth. I think this is a backbone for handling data in React or in any functional uh, programming paradigm in JavaScript. If I'm doing any other functional maybe framework for backend or front end, it doesn't matter. Okay, now let's go to managing state. I think hmm, I mean, here are references, and we covered in hooks only use state right until now, and it is the use state whole references. I think we went through all of this, but recapping all of this might be time taking. It will take whole session, I think. I mean, not right now, but I have a plan to go through important hooks like use effect, use state, use ref, use context, use this is a new one, use action state by the way. I mean some very I mean important hooks go through make single video out of one hook and spend 1 or 2 hours on a hook and really I mean understand I mean right now we understand React state use state but maybe we missed something. This is complete reference. I mean this is the most complete documentation over use state and going through this will make a more good hook user I think. Okay, there are React DOM 19 use form status components. Hmm, what is this one? Okay, let's uh, this is not stuff us. We'll go through managing state for now. Okay, So, be ready. Managing state. As your application grows, it helps to be a more intentional about how your state is organized and how your data flows between your components. I think I have a video downloaded from YouTube. I mean, because I downloaded because I don't miss this and again find this video. I mean, uh, I mean this will help. This video will help us to go through basically uh, more. I mean, understanding whole React data flow mechanism. I don't think no, this is not. This must be here. Authentication, benefits of learning, better auth, REST API, declarative, async. This is not. How I use AI, how to move REST API, big O not just testing, programming principles, programming principles, programming roadmap, sanitization, the network. Okay. TypeScript, understand validation controllers, what happened before, what is routing. I mean, I think I missed. Now I have to go to YouTube. Unidirectional data flow, I think. Yes. Uni data flow React. This was really great. I mean, 20 minutes plus. I mean, these are guys are really awesome, but this is 10 years old. They are using class components, and I don't want to bother myself with class components in this. This guy might help, but it's a really interesting Flux architecture. Not this, not this, not this, no, not this. Might be this one. Yeah, here it is. Flux, a modern way of doing MVC. Okay. Mm,
Hello, can you hear me? Okay. So you enjoy the conference till now? You do this? Okay. Hopefully you still do this after this talk. Um, so hi, my name is David.
And I'm Thomas, and we are both software professionals from Vienna. And today we would like to talk to you about the problem of UI state management in applications. And in particular, we want to go into Flux and MVC and how they are related.
So, besides being passionate software developers, Thomas and I have one more thing in common. We really like, hoppla, we really like React. So, who of you knows React? Okay, quite a few people. And who of you uses it in his daily work or in his side project? Okay, 3 people. Ah, that's not bad, but there's potential for us. So, Thomas and I, we talk a lot about technology, so we do this most of the time when we're not working. We talk about our work, so it's kind of a bad habit, but it is like it is. And when we talked about React, and we as mentioned, we like React and we like the way how to build web applications with React, we realized, well, React is only a small part of what we really like in building web applications in this whole stack. And we really like the way how React normally, or the way how you could manage your application state with React. So is everyone familiar with application state or state management itself, UI state management? Okay, now let's explain it very short. So UI state management at its core is very simple. So we took this definition from Martin Fowler, of course. Who else? So he says that applications have different kind of state. Yes, you have this record state, you have session state, you have screen state. So their lifetime is different, but essentially you have different kind of state in your application. And the real purpose of state management is to ensure consistency between the states. So to keep the state in sync. And with React, you normally achieve this goal of keeping the state in sync with something called Redux.
And so, yeah, we said we like React, but what we really love is Redux and how it works. And so the question is, what is Redux? Well, it's an independent library, independent from React, and it describes itself as a predictable state container for JavaScript apps. And as I said, it's independent from React. You can also use it with Angular, for example. Doesn't matter if 2, 4, 5, or I don't know what version comes next. And but you can also use it. You can also use it in an application that doesn't have a graphical user interface at all, like a CLI, for example. So it's just a library for managing application state. So when you take Redux and you combine it with React, you come up with something that Facebook calls the Flux architecture pattern.
Yeah. So it's Flux. So as Thomas mentioned, Flux was introduced first by Facebook. Who knows Flux? Okay, cool. So Flux is an application architecture utilizing a unidirectional data flow. So that's the definition of Facebook. So let's explain this very simple. So let's take a simple example. So let's think of an web application. So you have some kind of React application. And some users clicking on a button. So some user decides to do some user interaction. This user interaction then gets normally mapped to an action. Okay, so some kind of domain action. The user finishes some ordering process. So the click button gets transformed to user finishes some order. And then there's the dispatcher, which hands over this action to the store. And the store holds the state of the application. And whenever a new action comes to the store decides how to change its state. So probably in this case, he would set a Boolean to finished order or whatever. And every time the state in the store changes, all views which depend on the state are automatically getting re-rendered. So every time you change something in your state, all the UIs which depend on the state are automatically getting re-rendered. And what we can see here is that only this re-rendering part is actually performed by React. All the rest is implemented by Redux.
So if you're not familiar with Redux, these are some terms that are kind of weird because you never heard of action creators or anything. So in our opinion, a very important question to ask always when you're faced with new technology is why create something new? What's the benefit of creating something new? What does it do better than existing technologies? And so what about existing patterns like MVC or MVP? Why weren't they suitable for managing application state at Facebook? And there's an interesting answer to this question. There is an InfoQ article. I recommend it to everyone read it. And in this article, they explain that they did try to use MVC for their application, but it didn't work out for them. They had problems with inconsistently displayed UI state. So for everyone who uses Facebook, you all probably ran into this bug where you were chatting with someone in the chat window, and so you would like read the message, but the indicator at the top says, hey, you have a new message. And when you click on it, oh, there is no new message. So it's this kind of inconsistently displayed data that they had troubles with. And another statement that they have in this article is that they say MVC didn't scale for them. And when we were discussing this, we thought, okay, this is a pretty controversial statement because from our experience, MVC did scale pretty well. And so, yeah, we did what every professional software engineer would do. We Googled it, what is actually MVC and why would it not scale? And the results were pretty interesting, actually.
Yeah, I mean, the results are amazing. So you find the best UML on Google, and we just want to present you some of the search results. So the first one we got is here. So of course you have a controller, you have a view, you have a model, and you have this arrows. So everybody is speaking to everyone. So this is interesting, but makes not that much sense for us.
So the next result was a bit better. At least the errors are no longer bidirectional, but the view and model kind of keep updating themselves all the time, and we're not quite sure where input from the controller is coming. And yeah, I don't know.
Yeah, I mean it's very sophisticated. So skip all these errors, do gears instead. It's much better. So yeah, I mean it brings it to a point. No, it doesn't.
This one's also quite interesting because apparently our whole database is now the model. And also take a look, we have gears again. It's very important to have gears. But yeah, all of these diagrams or pictures didn't really make sense. So we did some better research. And of course, again, Martin Fowler comes up. And he has this very interesting article in which he says different people reading about MVC in different places take different ideas from it and describe these as MVC. And this pretty much brought it to the point, the whole confusion about, okay, what is MVC actually? Why is there so much, why are people thinking so differently about what MVC actually is?
Well, and who of you has seen the talk from Adam Thornhill yesterday? Great talk. I've seen him. Okay.
The keynote.
Yeah, keynote. So, did you realize the MVC pattern he introduced? Well, it was this one. This is also very interesting. So, probably it's very clever to leave all errors away because this confirms what Martin Fowler says. Yeah, it's not sure. It depends on the context how you really see MVC.
So now if you do some more serious research about MVC, you sooner or later end up with this guy whose name nobody can pronounce because he's from Norwegian, I think.
Reinskog.
Trygve Reinskog, something like that. And so he's the inventor of MVC. He first described this pattern of MVC back in the old Smalltalk days. Who was alive back then? Okay, yeah, very young conference. Sorry. So in this paper, Trygve describes this idea of what he wants to achieve with MVC and what it actually is. And so for models for him, there's a very short sentence that describes this pretty good. He says, models represent knowledge. Models describe a concept of the real world, like a to-do item, something that is, it's an abstract term. And so the models are completely ignorant of how they are represented and how they are interacted with. And next to the models, there's the view. And the view's only job is to create a representation. And this is, in our opinion, a very common misunderstanding. The view is not the representation of the model. The view is a class that creates a representation. And so this means data flows from the model to the view. But the model doesn't know that the view even exists. So the association goes into the other direction. And the third element is the controller, obviously. And the controller's job, described in the in the terms that Dragway uses was the controller is the link between the user and the system. So it's the controller's job to map things from the user to abstract events or commands to this model that doesn't know that it's even presented somewhere. And a very interesting finding, in my opinion, is this boundary here that like tells us that we're operating on different abstraction levels in our software. So the model is on a different abstraction level than the view and the controller, because these two deal with technical details of the presenting stuff, while the model doesn't know about that.
Yeah. So let's apply all this to the good old web. So finally some source code on our presentation. Do you like it?
David, this is the Java conference. This is way too concise.
The Java conference. So write some real Java code here. So no, getting serious again. So let's apply all this to the web. And what's really interesting, the pattern Reenskog described can be applied very simple to the web. So let's take a look at it again. And all that really changes is, okay, the controller takes an HTTP request with some user action normally, transforms this to some model change actioner, and the view re-renders the new state in the model and returns us with an HTTP response. So we can see two things here. The first one is everything is on the server. So the whole MVC pattern is implemented on the server. And the second thing, which is very interesting, there's no JavaScript, and we all know this has changed.
So let's take a look at how things evolved with the introduction of JavaScript. In order to explain that, I want to quickly walk you through this nice little to-do application that has completely irrelevant items. And so you can mark them as done, but you can't undo them, so make sure you actually do them before you click on the button. And if we don't have JavaScript, this means only the view can create us a new representation. So if we click on the button, we issue an HTTP request, and we get back a new view. Now this user experience sucks, because it's like the whole view refreshes and the whole UI refreshes, and despite that we only want to make this little item green. So we introduce JavaScript, and if we do this, we make an asynchronous HTTP request, of course, and we get back some JSON, and then we just modify the HTML on the client.
So
now
we could get back some JSON.
We could get back some JSON, but we know how things evolved, and today we are only doing JSON and then call it REST. So what happens now is that we introduce duplication, because this class here that says how does an item look that's done in the CSS, we duplicated that, because our JavaScript needs to know what this class is, and our view knows. And yes, I'm aware this is a very simplified example, and you can probably get around that, but it should demonstrate that the more functionality that you put into your JavaScript, the more duplication you're causing in the view and in the JavaScript. So the question is, how do we tackle this problem of duplication?
I don't know. Anybody knows how to tackle duplication? Okay. Well, actually, I know only one real way to tackle duplication, and this one is very simple. Yeah, delete it or get rid of it. So that's the only way I know. And basically, that's exactly what happened in the MVP or in the JavaScript. So people started to implement MVC with JavaScript. So that where we went to. So people started doing all this stuff which was currently done on the server, on the client with JavaScript. So they did it with MVC, for example. They did it with MVP. They did it with MVVM. They did it with MV whatever, yeah, how they call it at Angular. But basically, that's what they have done. They did all this what was done on the server, on the client now. And, well, there are lots of implementations of MVC in JavaScript. I like this one from Peter Michor. I'm pretty sure you don't know it, or does anyone know this? Yeah, I didn't know it either. But it's really good, because what he tries to do is he really tries to implement the design or the pattern Reenskog described for Smalltalk with JavaScript. So this is very, very, very near to the original thoughts from Reenskog. So this is really interesting. And of course, there are lots of others. And in our opinion, another MVC implementation in JavaScript is React plus Redux.
And so now, before you grab your tomatoes, let us explain why we think this way. And it's actually quite straightforward. So in MVC, we have three components. We have a view, and we can try to map these two elements of a React Redux application. And so what is the view's job? The view takes data and creates a representation of it. Yeah, I think I don't have to repeat this anymore.
Well, can I repeat this more? Because it's so important, and it's such a common misunderstanding in MVC applications or in MVC frameworks that the view is actually the HTML, and this is not correct. In my opinion, it's not correct, because the view is the component which renders the HTML. Okay? So the view maybe uses some HTML template and renders a HTML out of it, but the view itself is not the HTML. Just to make this clear once more.
Yeah, thank you, David.
You're
So
welcome.
what can we map this to? Yeah, we can map it to React. This is what React is doing. It takes data and it creates a representation out of it. And why is this true? Because it's also on Wikipedia. Wikipedia says that React is the view part of MVC, and Wikipedia never lies. We all know this.
So go home and read the rest on Wikipedia of what we're saying. Because
Okay, no.
Wikipedia never lies.
Second part, model. What's the model's job? Models represent knowledge. It means that models implement your business logic. Models implement all the business rules that you have, and they encapsulate state. So how is this handled in Redux? Well, it's the Redux store. The Redux store encapsulates your data. It takes actions and it transforms the state based on these actions. So these two can, literally be mapped to one. Yeah,
Yeah, things getting a little bit strange with the controller.
because we're already done with this, right? So where's the controller?
Yeah, the controller is a little bit of a strange guy. But let's reconsider what was actually the purpose of the controller in MVC. As Thomas mentioned before, the controller takes some user action and transforms it to some model transformation action. So it takes a user action, transforms it, the model changes. And when we think back to the Flux architecture I showed before, so there was this UI, this React UI. So the user has some user interaction. This interaction gets mapped to an action. This action, or this dispatcher hands this action over to the store, and the store finally gets updated. So I think you get it, that the main idea, the main goal behind this is pretty much the same. There's just some other wording and some more components, but the controller basically is some array of components in Redux, I would say.
Yeah, more or less.
So yeah, I'm still on. So as we can see, the structure is very similar. So we've proven this here, or we tried to prove this here, that the structure of MVC and Redux plus React is quite similar. So, but the structure isn't all. So we know frameworks deliver more than just structure. They have some kind of goals. So let's take a look at the goals of Flux. So we took a look at the documentation on GitHub, on things people from Facebook said. What are the main goals of Flux? What are the main goals of the Flux architecture? What purpose has React and Redux together? What problems does it solve? And we found four very important selling points or main criteria they always speak of. And the first one is unidirectionality. Does anybody know unidirectionality in UI state management? It's familiar to unidirectionality. Okay, so basically the idea is very simple. If I take a look at Flux again, so we have this React UI. This triggers some kind of action. The dispatcher hands this action over to the store. The state in the store changes. Boom, React view gets re-rendered. And what we can see here is we have this always in this circle of direction. And according to Redux and according to the Flux team, this makes application very easy to understand and also easy to test, because you don't have anything from the React to the store. You always have this circular direction. How does this work in MVC, Thomas?
Yeah, actually exactly the same. So we have a controller, a model, and a view, and we always go in this circle. So we never update the model from the view. We always go from the controller. Yeah, that's basically it. It's exactly the same, actually. The thing is, there are other approaches to this. So not every UI state management framework is unidirectional. If you think of MVVM, for example, that's implemented by Angular, you have binding, and binding is always bidirectional. And then you don't have this nice circle of, okay, I always know where my data comes from, because you're not quite sure which of the two parties updated the state.
Okay. So another selling point Flux always argues with is predictability. So, well, this one is also quite obvious. So you have some state in your store, you have some action, you again have some state in your store. So if you have some state in your store and you apply the same action again, you will get another state. And you can do this again and again and again, and it's quite predictable. So you know how actions will change the state in your store, and you could describe this with a very simple function. So the store state plus an action is a new store state. But this one is always predictable. If you know the store state and the action, you know the new store state.
Yeah, this is also the reason why it's usually implemented in the form of pure functions. And the thing is, if we just take this to the object-oriented world, it's like the same thing in MVC. We have a model that has some initial state. We apply an action, which is probably a method call, or we send it a message, and we get a new model state. And this can be tested in exactly the same way as the Redux variant.
Yeah. So the third point, single source of truth. So the single source of truth in Redux is quite simple also. We can see it here, the store. So the store in our Flux architecture is the only way where we store our state. So there's no second store, I'm cutting corners here, you could have a second store, but it's on the same position then. So, but all these other things here don't have some kind of state. Of course, you have some very short-living state, but it's not really persistent. So all your state is located in this store. And of course, this is a big advantage because you know, okay, the only way to update your store, as we have heard before, is to create an action and apply it to the store. And so it's very easy to understand what's currently going on in the application. So you can retest stuff because you only need the state of the store and apply it to the current running instance of your React application. And this is where single source of truth is really big, because you can do this. In lots of applications, you have state everywhere, sorry. And this is one of the really big advantages, I think, which come with Flux. So
yeah, I think you got me with this one, because we now have 3 models or even more. And it seems like state is now scattered across the application. But if you take a closer look, and might be more easily be seen from like the last rows, all of these models could be seen like this is my application model, and I could reference them from each other. So more or less you have a single source where you go to for if you want to know about a particular state. And also if you look at it from the context of the information that is stored, whether or not a particular to-do item is done or not is only ever stored in one place. So it's never scattered. You don't have to like combine 3 Boolean values in order to get that information. It's always the single source of truth of information is still valid.
Yeah, so no duplication is the point here.
Yeah.
Yeah, the next one, consistently display data on the UI. So this is where they got me. So I figured, I didn't know exactly when I became a fan of the Flux architecture, but this is really the thing where I said, wow, I go with Flux because it's crazy. It's that easy, and it makes things so easy. Because for me, the real big advantage of Flux is, as I mentioned before already, so you change something in your state by an action. So that's the only way to change your state in a Flux architecture. And you don't have to do anything, because all the views in your application, all the UI components, know on which state they depend on. And if they recognize, okay, the state I'm depending on changed, Okay, then they re-render. So this is not my beer anymore, and they do it on their own. And you can describe this again with, of course, some very easy function. The view takes a store state and renders an UI.
Yes, and with MVC, it's again exactly the same actually. They even use, so if you look at Smalltalk implementations of MVC, they even use the same pattern. It's the observer pattern in both places. So views subscribe to models and React views subscribe to the store, and any kind of updates just get propagated to all the subscribers, and they can re-render as soon as the state changes. Of course, there are some optimizations to it. Okay, if the state I depend on doesn't change, I don't re-render, but the idea is the same. You don't have to specifically tell the view, okay, now go update yourself, because it already knows because of the state change that was the actual intended behavior.
So well, what we basically said, it's all the same. Yeah? So structure is view is React, model is store, controller is some array of React components, and the goals. Both fulfill some kind of the same goals. Maybe Redux and React is some kind of more opinionated to achieve these goals, but basically the goals and the structure is mappable. So what we say is that you can achieve what you can achieve with MVC can also be achieved with Flux. So does anyone remember the title of this talk? Come on. We saw that. Okay,
Shit.
so one guy, what was it? Right. Flux, a modern way of doing MVC, question mark.
So it probably should have been just Flux, another way of doing MVC, because this is what it all comes down to, and we hope we were able to convince you that the differences between those frameworks or approaches are so marginal that, in our opinion, this is just another way to do MVC, because both want to achieve exactly the same things. They just use different terms and structure everything a little bit differently. And as we've seen, almost exactly the same.
So why is this important for you? And now it's really getting interesting for you, I think. So wake up and listen 2 minutes. Why is this so important, this message? Because, I mean, don't get me wrong, and I think I can also speak for Thomas, we both like React, we both like Redux, we implemented a couple of applications with the stack, and probably we would do it again.
There will be some more.
There will be some more, and we would do it again. But the problem really is, when you start talking with some React developers normally, or some JavaScript experts, or some other guys who use Flux a lot, they normally say, come on, use Flux in your application, you got all these big advantages. Yeah? And then you ask, what advantages? Yeah? And then normally they tell you one of the 4 points, one of these 4 key goals we showed you before. And then they say, come on, use it. Come on to this React land and use React, and probably buy some training from me, and we will train you how to use React really. And this is interesting because, as we have seen, Reenskog did this 40 years ago. So 40 years. Reenskog had some pattern in his head or in his mind, or described some pattern which basically fulfills the same goals and same structure like Flux does now with other wording. So if you really should take one message from this talk, it's probably that you shouldn't do this hype-driven development. You shouldn't follow these new buzzwords. So you should not learn frameworks at all, I would say, because this doesn't scale. You can't learn each new JavaScript framework. But what you should do, of course you should learn, but you should probably learn the concepts behind these frameworks. Because when you understand the concepts behind this framework, this is some real big value for you as a developer, because you can reuse them, as we have seen, from Smalltalk till now to JavaScript. So, as mentioned, learn concepts, not buzzwords. So, thanks.
Yep. Thanks for listening. Just a quick few words about ourselves. So, as I already introduced myself, I'm Thomas, And yeah, feel free to approach me and talk to me. However, if you want to do this, do it in the next 3 weeks because I'm going to meet this guy again, going to Sydney in April. But yeah, but follow me on Twitter, ask me any kind of questions, whatever you like.
Mhm. Yeah, I'm David. I'm working as a freelancer in Vienna, mostly on Java and JavaScript. So sometimes .NET when I run out of money. No, just kidding. .NET is has some really interesting ideas and concepts, I think, beside the new frameworks. Yeah, that's it for me.
Yeah, and we also do like to make software in our free time, and so we have this little project, and we just advertise it here a bit. It's called Not.io, and whenever you run into the situation of being around with a few of your friends and everyone has a bill, someone pays the coffee, someone pays the beer, someone the fuel costs, and you don't know, okay, how to split this up, give it a try. It's
Okay, the talk was awesome, and we got to know about Flux architecture. Basically, Flux architecture, what it is, and I mean, this is, I think, a great intro to Redux for me, which we will learn, and I mean, unidirectional data flow, how one event set. How event can create an action and create action go to dispatcher and dispatcher update the store and store with the store all the over state of the UI will get synced and how this behaves all. Okay, and what is unidirectional data flow? This is unidirectional, like one action uh, only data live in a single source of truth in a state, and only via action to dispatcher and dispatcher to we can update a state, update a store. This way we can update, and this is a unidirectionality in React. I think we will go more deep in unidirectional data flow later someday, but for now we will complete this section. I think one section of the documentation today, and later we will go more more deep. I think in unidirectionality, but I mean, as a whole, we know React is React plus Flux architecture or Redux is I mean just another representation on a front end or on a UI MVC. I mean, way to do MVC differently. I mean, let's not go really deep, and let's go through these docs, and later we will go through more React data architecture, how React handles state and data. I mean, this is most important, I think. Okay, how declarative UI programming differs from imperative UI, how enumerate the different visual states your components can be in, how to trigger changes between different visual states from code. Let's go to, my mind is questioning what is unidirectional data flow even. What is uni unidirectional data flow in React? How declarative UI to imperative. Okay, declarative UI, when you design UI interaction, you probably think about how the UI changes in response of user action like click. Consider from, let's use submit answer. When you type submitting into the form, submit button becomes enabled. When you press submit, both the form and the button becomes disabled and spinner appears. Okay. The network request succeed and then gets form gets hidden and the thank you message appears. If network request fail, the error message appears and the form becomes enabled again. In imperative programming, the above corresponds directly how implement interaction. You have to write exact interaction to manipulate UI and what just happened. Here's another way to about imagine it riding a next to someone in a car and telling them to turn by turn where to go. Okay. They don't know where you want to go, they just follow your commands and you get directions wrong, you end up the wrong place. It is called imperative because you have command each element from spinner to button telling computer how to update UI. In example of you imperative UI form build without React, it only use React DOM. I don't wanna see even. I mean manipulating DOM. Leave it. Manipulating UI imperatively works well enough for isolated examples, but it gets exponentially more difficult and to manage a more complex state. Imagine updating a page of a full different forms, like one adding a new element and new interaction would require carefully checking all existing code to make sure uh, you haven't introduced bug, for example, forgetting to show or hide something. Okay, when it, I mean, become more code, more frustrating it will become, I think. Okay, React was built to solve this problem. In React, you don't directly manipulate UI, meaning you don't enable, disable, show, or hide component. Instead, you declarative what you want to show. React figures out how to display, update the UI. Things are getting a taxi telling your driver where to you wanna go instead of telling them exactly where to turn. It's driver job to get you there, and you might even now some structure you haven't shortcuts you haven't considered. Okay, thinking about UI declaratively. You have seen to implement imperatively above to better understand how to think in React. You will walk through re-implementing this UI in a React. Identify your components, different visual state, determine what triggers those state changes, represent the state memory in memory using useState, remove non-essential state variable, connect the event handler to the set state. In computer science, you may hear about state machines being in several states. In if you work with a designer, you may have seen mock-ups in different visual states. The X stands at the intersection of design and computer science, so both of these ideas are source of inspiration. First, you need to visualize different state of UI. Empty. Form has disabled submit button. Okay. Typing form has enabled submit button. Submitting is a form is completely disabled. Spinner is shown. Success. Thank you. Message is shown instead of form. Error same as typing state. Okay. Just like a designer, you will want to mock up or create mocks for different states before you add a logic. For example, here's a mock for just a visual part of this is a mock controlled by a props called status and default value is empty. Okay, if I'm writing it's oh what happened? You know, okay. export default form, status is empty. Okay, we are getting this via prop. If status is success, return that's right. Okay, uh, if if not, then return city quiz. Okay, we are not setting a status. So any time we will click this, we will get back same, I mean this one. Okay, this markup again. I mean same page. Let's go. You could call that prop anything we like. Naming its status is empty. Status success to see success message appear. Okay, but you told me earlier that you should not. You should really not. Okay. I'm typing here. Nothing is happening, by the way. Show more. Status is empty. If status is success, that's right. Okay, if not, if it's empty, I mean, how do I make a status as a success? Go, D. If a component has a lot of visual state, it can be convenient to show all of them in a one page. From empty, from typing, from submitting, what's going on? Okay. Okay, we can show them for, I mean, referencing them later. Uh, kind of living mockups. Determine what triggers these state changes. You can trigger state updates in response to kind of human inputs, computer inputs. Image uploading, okay. In both cases, you must set state variables to update UI. I mean, because in React, anytime you want to update a UI, you must have to update uh, state, and state will be synced with UI. Like in, okay, in changing the input, humans should switch empty state from typing state to back to depending on whatever that box is empty or not. Clicking the submit button, human should switch. Successful network response should switch the success state. Failed network response error state. Okay, 7:25. I mean, I'm getting late to go to. Notice that human inputs often require event handlers. Okay, typing, submitting, network errors. State is empty. User starts typing. State become typing, and when we press submit, it's become submitting. And now it's dependent on network. If network error state. If network success state. Okay, this is a form state. Not needed. Okay, where I can. I mean, what's going on? Step 3, represent the state in memory with use state. Okay. Next, you will need to represent visual state of your component in a memory. Use state simplicity is the key. Each piece of state is a moving piece. You want as few moving pieces as possible. More complexity leads to more bugs. Start with the state that absolutely must be there. For example, you will need to store the answer for the input and error if it exists. Okay, uh, uh, start with the state that absolutely must be there. For example, you will need to store the answer for the input and the error if it exists. to store the last error. Okay, I mean all of these states must be in components memory. Okay, the first idea will likely won't be the best, but that's okay. Refactoring state is a part of the process. Non-essential state variables. Empty is essential. Typing is kind of maybe not essential. Is submitting is essential for the UX purpose. Is success is essential. Everything looks. You want to avoid. You want to avoid the duplication in state content. You are only tracking what's essential. Spending a little time on refactoring a state structure will make your component easier to understand. Yeah, like we should spend a lot of time on building or developing a model for our application. Consider state as a little model of your UI and put a more effort and time. Reduce duplication, avoid unintended meanings. Your goal is to prevent the case where the state in memory doesn't represent any valid UI that you had you don't you had want to user to see. For example, you never want to show an error message and disable input at the same time, or user won't be able to correct the error. Does the state cause paradox? For example, is typing is submitting can both be true. A paradox usually means the state is not constrained enough. There are four possible combinations of two booleans, but only three. Hmm, what's going on? To remove impossible state can be combined status what typing, submitting, or success. In the same information available in another state variable area, another paradox is this. I don't want to spend time right here. Let's go. Connect event handlers to set state. Okay, we will connect event handlers. Now look at unidirectionality here. Event handler will do a side effect and update a state. I mean, updating a state, think as a action. I mean, events take an action and action update a state and state change resyncs a UI. I mean, state consider this state as a mini store for component. Okay, now this will work like intended. Good guess, but wrong answer. Try again. I don't care what answer is, but I mean nowadays we don't need to do with our hands all of this stuff. Libraries like Formic or React Hook Form do all of this, and they give a more declarative way to do this. I mean, we'll go through later, I think, but for now, this is when developing a component. When we go through a state, I'll not do exercises. Maybe should I do? I think this is an important part. I will do. Challenge one of three: add, remove a CSS class. Okay, make it so that clicking a picture removes background active CSS class from outer div, but adds a picture image. Clicking background again should restore with original CSS classes. Visually, you should expect by clicking. I mean, for clicking, we need an event handler. For changing classes, it means we are changing the state. We need use state. We need to change the state. And now the last thing is back to normal. So we must have three types of state. Maybe I don't want to show the solution. Let's go through this for now. Okay, can I make this little bigger now? I can do this. Okay, let's first of all, first of all, make it so clicking the picture removes. Okay. Hmm. Let's say const something is equal to use state. I mean, how to import use state? I think use state. So now it's let's say uh, no let's class name set class name would be better. Background. Uh, I mean I don't want to write a whole background and copy and set background. Okay. Use state is not defined. I mean, where do I define? I think I need to import use state. I can do this. No, I'm in browser. Think import. I mean, use state. How do I import use state? I mean, uh, copy from somewhere. Yes, this way. I don't care about snippet. I mean, import. I mean, why not paste and stop time to waste? Use state is not defined. What the hell is going on? Capital S. Now we are good to go. I mean, now, mm, clicking a picture removes background. I mean, can I make it bigger somehow? Can I toggle this back and make my screen bigger? No, no. Clicking an image removes background active. I mean, let's say we just implement this, okay? Just implement this for now. Okay, for now, okay. Use state value of use state is this thing for now. Okay. By the way, now here on click handler, maybe this is equal to handle click and yes, const handle click is equal to uh, do something on click handle click. Now here we will do. We don't have events above, but may they bubble up. So I'm gonna do little. I'm gonna be little responsible and do all error or all kind of I mean, default handling. And this is not necessary, I think, but let's be a responsible person. E E dot stop propagation. I mean, I don't know how to E dot stop propagation. Okay. Yes. E dot stop propagation and e dot prevent default. Come on. Yeah, this is e dot stop propagation. E dot stop propagation and e dot prevent default. Now we don't need to take anything from e. There is no way to show complete. Okay, now set. This should be a bob band. Okay. Set background color as, I mean, for now I think nothing. Now this will work. No, why no? This should work, man. Okay, I made a little mistake. Background. Okay, if you want me to do this way, no. What's going on? Mhm. Let's log. I mean, how to get a console? I mean, we are getting nothing in console on clicking. Okay, let's leave it now and let's copy this and go to VS Code. I think there I will do better. What's going on? I can't debug right here. I mean, let's go to part 2. Okay. Picture active class. Okay, let's change the class and right here. Copy this code and let's reset. Yes. And we'll paste this code back. Now let's see what's going on. Nothing is happening. Why? I mean, leave the shadow and deep copy. Come and main JSX. Let's create a simple component. Shelling one.js. Put this right here and do F2. What's happening, man? What wrong I did? Shelling one.js. Come on. Do F2 and copy this X and come on here and do this. Let's do npm run dev. Dot npm run dev. Okay. 741. Okay. Thing picture. Okay. Name is picture. I think remove this counter and all of these guys. just keep div right here. Okay, remove all of these. Okay, props, use state, and name, all this. Go to here for a picture, and let's see. Not two times, just one time. Wait, let's see. There's a picture, and he is getting picture active is here. So the class picture active is here, but um, class name is background. So background with e dot. Let's remove these guys for now. Thing. Now let's see. Class names are not here. Let's see. Remove this handle click and keep this handle click. Okay, this is working. I went there, and clicking it back is not. Working. Okay, clicking is working, and clicking it back. Now clicking on background restores original. Okay, on background now. Okay, on background. What is background here? Okay, here we will add one more event on click, I think, and on click we will do handle background click or handle bg click. That might const handle bg click is equal to this way. Okay, and set background to what? To background active. Okay, we completed the exercise. 15.15 something, 15.39. Okay, handle bg click. You want me this way? No. This is working. We create a little kind of toggly stuff. Okay, let's go to next challenge. Profile editor. Profile editor, it is a small form implemented in plain JavaScript. Don't play with, understand its behavior. I'm not interested to play with this. Refactor imperative solution. Use a lot of use states here. Okay, I don't want to do this basically. This is not. We went through this already above, and I don't want to go the same thing again and again. Let's go to next section. Choosing a state structure. Structuring well can make difference between component that is pleasant to modify and debug and one that is consistent constant source of bug. Here are some tips you should consider. You will learn use of single versus multiple state variables, how to avoid when organizing what to avoid, and how to fix common issues with the state. Principles for structuring state. Okay, when you write component that holds some data, when you write a component that holds some data, you will have to make choices about how many state variables use what shape of their data should be. While it's possible to write correct programs even with a suboptimal state structure, there are few principles that can guide you to make better choices. Okay, group related states always, it's if you update two or more state variables at the same time, consider merging them into a single state variable. Like two variables primitives, we can turn them into an object. Okay, avoid contradiction in state. When the state structure is a way that several pieces of state may contradict or disagree with each other, you leave a room for mistake. To try to avoid this. What it means, I don't get it. Avoid redundant state. If you can calculate some information from a component props or its existent state variables during rendering, you should not put information in the component state. Okay, avoid duplication. When the same data is duplicated between multiple state variables or within nested objects, it's difficult to keep them in sync. Reduce duplication when you can. Avoid deeply nested state. Deeply hierarchical states are very convenient and is not very convenient to update. When possible, prefer a state structure to flat. Use immer. Why not? It will flatten away your state. Okay. When I was reading this, it's looking like I'm reading database normalization, database stuff. I mean, we're designing a database like principles or guidelines to design a database. The goal behind design, the goal behind principle to make state is easy to update without introducing mistake, removing redundant duplicate from data helps to ensure that all its pieces stay in sync. This is similar how database engineer we might want to normalize database structure to reduce chance of bugs. To preface, Albert Einstein. Oh, Einstein also teach CS. Make your state as simple as it can be, but not simpler. What's going on? What is going on here? I mean, this is Einstein, or I mean, or I'm reading wrong. Let's go. I mean, group related states. Okay, okay. I mean, X and Y. And you might sometimes be unsure between using single or multiple state with should you do this or this. Technically, you can use either in these approaches, but if you two state variables always change together, you might it might be a good idea to unify them in a single state variable. Then you won't forget to always keep them. Like if I'm updating X and I'm updating of Y also. I mean, both get updated in the same time, then I need to keep them in a single one. Why not? Okay, okay, okay. Another case where you will group data into object array when you don't want many pieces substitute. For example, it's helpful when you have a form where user can be add custom fields. If your state object is a object, remember that you cannot update only one field in it without explicitly copying. For example, set position x100 above example based, it would not have a y property at all. Instead, you want to set x alone, you would either do set position dot 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 position x100 or split them or use emerge. Avoid contradictional state. I mean, state are conflicting with each other, like text. Text here is sending is sent. Is sending and is sent. I think are contradictory. What's going on? This is confusing even for me. I know. This is need some serious thinking to. If this is a AJAX request, then is sending is go and is sent instantly become true. While if a request failed, what happened? What's going on? There are a lot of edge cases missing. While this code works, it leaves door open for impossible state. For example, if you forget to call set is send and is sending together, you may end up situation where both is sending and is sent are true at the same time. To more complex your component is, it's harder to understand what happened. Since is sent and should never be true in the same time, it's better to replace them in a one status make variable that may take one of three valid states: typing, sending, or sent. Okay, yeah, this is clean. This is remembering me a little bit about React Query. Okay, this code snippet. You can still declare some constant for readability. Okay, both are not state variable, but you don't need to worry about them getting out of sync with each other. Avoid redundant state. Uh-uh, uh-uh. Full name. We don't need this. Okay, let's go. Easier one. Easier one. Don't mirror props in a state. Function message color set color is equal to message color. Don't do this. While we are getting props, we are getting somewhere from state. Why we need to put again in a state? Yeah, we can rename. Here is a color state variables initialized in the message color prop. The problem if the parent component passes a different value of message color later, for example red or blue, the color state variable wouldn't be updated. This state is only initialized during the first render. So this is why mirroring, what if props changes? The initial thing will be get disturbed. Okay, the mirroring state some props in a state variable can lead to confusion. Instead, use message color prop directly. If you want to give it a shorter name, use constants. Okay, Instead, only makes sense when you want to ignore all updates and specific profs by convention. Start a prof's name with initial or default. Okay. Avoid duplication. The menu list. I mean, somewhere we are. Let's go to this code. Mm, import use state initial names, initial items. Okay. This. Initial items are here. In a state. Selected items. Set selected items. What we are duplicating. I mean, what we are duplicating right here. If I choose, mhm, we are setting selected item to items. What's wrong in a code? Okay, we can remove this. Basically, we are doing same thing in selected and this, and just play with this. No, this is not a good thing. What to do? Let's see. Currently, it stores selected item as an object state variable. However, this is not a great. The constant of the same object as a one of items list. This means data information about itself is duplicated into place. Okay, we can play in. I mean in initial items also. Like let's make each of them editable. Like if I do this, this will not reflect. Okay, because it's in a different state. This is a duplicated state. You forget to update a selected item. Okay, although this could update selected item too, easier to fix. To remove duplication in this example, instead of selected item object which creates a duplication of with the object instead inside items, you can hold selected id in a state. You can searching items and whatnot. Okay, we can keep just IDs. Okay, now a state is living in a one state variable, not two. And okay, deeply nested, I don't think we will use this deeply. Yes, we should avoid. Mm, I don't want to go this. Mm, use immer always. Try out some challenges. Not now. I mean, we go through these two sections today. I mean, trying out some challenges tomorrow. I mean, hopefully we'll take do a recap of this and take challenges and add 2 or 3 more sections went through, I think, and then we'll back to full stack open. We can be back. We can go back from today and I mean, maybe I do a the next session today, and then we will go through these sections someday later when we need them. And this is it for today. Next day we'll learn more about, we'll read more about full stack open and we will progress in a course. Thank you.